Evaluate. What does evaluate mean in math words? Solve. Find what x is, right? Simplify means you're just making it simpler. It doesn't mean that you're actually going to find out what it equals at all, right? But solve or evaluate means figure out what the heck this is equal to. So log base 2 of 64. Without using the log base button, how could we figure this out? There's two ways. Without using the log base button. You could go log 64 divided by log 2. Or we could go 2 to what power is 64? I think it's 6. That would be our answer. B has log base 2 of 1 over 32 equals x. So 2 to the what is 1 over 32? Negative 5. Now, this is a rule that people forget about. If you have the base of your exponent is the same base of your log, your answer is just what's beside the log. So it would be 25. And why would that be? Because this is 5 to the what? So 5 to the what is 25? 2. So log base 5 of 25 is 2. And 5 squared is 25. So you need to remember that if your base of your exponent and your base of your log are the same, your answer is this. Why do you need to remember that? Because they'll give you something like this. A log A B. What's your answer? B. And if you're ever stuck, can you not fill in values for A and B and see if you could maybe figure it out that way? Yeah. Okay. D. What base is there on that log because there isn't one? 10. And what's 0.001 as a fraction? One over what? 1,000, I think. So 10 to the what is 1,000? 3. So 10 to the what is 1 over 1,000? Haven't had to touch our calculator yet, right? Okay. Oh. What's C? X equals 6. Yeah. Remember, if you have base to the exponent, and these two base to this is the same, like 5 to the 5 to the 6, your answer is 6. Because you could say it's the same as 6, because the exponent can drop in front on logs. Log 5 to the 5. And what's log 5 to the 5? Just 1, so it's 6. Now, we change from log to exponential whenever you're missing the base or the number beside. So if we're missing the number beside, which we're doing right now, all you're going to do is switch it to exponential and solve. If we're missing the base, like we are in F, we're going to switch to exponential and solve every single time. When you have one log and you're missing the base or you're missing the variable beside, you're going to switch to exponential and solve every time. Okay? So base of my log becomes the base of my exponent. What's with it doesn't stay with it. So this is now going to be with it, the negative 4. And it equals x. And now it's easy to solve, right? Once you change to exponential. But if you forget to do that, then you're just sitting for a while. Could we y1, y2 this? Yes, it's an equation with one variable. Absolutely y1, y2 it. They'll do a way that will force you not to be able to y1, y2 it. So don't always just bank on that, okay? But you can check it that way. So this would be x equals, so 3 to the 4 is what? 81. So 3 to the negative 4 is 1 over 81. F, we would have x to the 3 equals 64. Base of x, 3, 64. Worst thing you can do, well, it's not the worst thing you can do, but stop getting into this habit. Don't cube root it. Don't cube root it. Cube rooting works. However, When we get some crazy fractions and stuff like that, or we get variables, cube rooting won't work. So I would like you to always get used to, because I know you can cube root this, get used to getting rid of it by exponents. So this is 3 over 1. What exponent could I raise it to get it to be 1? 1 over 3, the reciprocal. And then I'd raise this to the 1 over 3, which is technically cube rooting it. Okay? So it would be x equals 4. Is that what it was? Cube root of 64. So cube rooting it isn't the end of the world, but what's going to happen is you're going to get some stuff with variables in it, and you won't be able to just cube root it in your calculator. You're going to have to distribute the third in, so you need to know to do that. And then these are little reminders of rules that everyone forgets about. So if you have log a to the m, your answer is just m. If you have any base to the 1, why would it be 0? Because you would ask yourself, a to what exponent is 1, which is 0. So that's what that works. Okay? A to what exponent is 1? 0. Anything to the exponent 0 is 1. And then base a, x, it's x. So this one here, I'll rewrite it because it looks so tiny. It's a log a to the x equals. Okay? Everyone have those? So these are just practice questions you can practice. I want you to try them for now, and then we're going to go through them. Okay, you try these. Then we're going to go through them. All right. What's the domain? X such that x is greater than 10. Why is it greater than? I haven't drawn even the graph. Because there's no reflection in the... Ooh, went to go with y there. No reflection in the y-axis. Are there any x-intercepts and y-intercepts? There's a x-intercept, but there is not a y-intercept. How could I find the x-intercept? I could go 0 equals log base 10 x minus 10 minus 1. I'm going to put the base 10 there because it's going to help me find it. So remember, if we're missing the x beside the log, or we're missing the x in the base, we convert to exponential, correct? The only way we can convert to exponential if we have log equals something. Right now we have log minus something equals something. So the first thing we have to do is actually move that 1 over, and then we can convert it to exponential. So we're going to get 1 equals log base 10 of x minus 10. And now we can change it to exponential. That's why I wrote the base, because you need the base in order to convert it to exponential, right? So it's going to be base of 10 to the 1 equals x minus 10. And the reason why I changed it is because if you don't know this, you don't know this, you convert it. Okay. Add the 10. And you have x equals 20. So your x-intercept is at 20 and 0. Yeah? Now, if I wanted to actually draw the graph, could I just put in the basic log function and then do mapping? Yeah. Because I moved every point 10 to the right and 1 down. So your mapping notation would be x plus 10, y minus 1. And we can just move every point, right? What's the catch with example 2? There's a negative. You have to take the 2 out, or you're going to get your horizontal translation wrong every time. It doesn't matter. They will do that on the diploma. Throughout the diploma. Yeah. So y equals negative log 2 x plus 3. Because remember, the x has to have a 1 in front of it in order to tell our horizontal translation, and it doesn't right now. It had a 2. It's also going to throw off our asymptote. It's going to really just destroy everything if you're going to take that number out. So remember, what's the asymptote? At x equals -3, because it moves 3 to the left. What's my domain? Is there a reflection in the y-axis? No. So it's x is greater than -3. It didn't flip. The reflection is in the x-axis, so it just caused it to decrease, but not actually anything else. And my range is y. Yeah. I need to have a negative in with the x in order for it to change that inequality sign to less than. Are there any x-intercepts or y-intercepts? There's x-intercepts for sure. And there's y-intercepts because x is greater than -3. So I have like, and then it's going, right? So it's going to cross through on both sides. So yes. Let's find them. So y-intercept, I fill 0 in for x. So I'm going to get y equals negative log 2, 0 plus 3. So I'm going to get negative log 2, and then 2 times 3, which is 6. And so it's going to be a decimal. And then to get the the x-intercept, sorry, you fill in y equals 0. So we're going to get 0. And I'm just going to use the original. Now I told you, in order to find what's beside here, it needs to be a log by itself equals a number, correct? It's not a log by itself right now. There's actually an exponent here, or a coefficient here of -1. So I have to divide the -1 over first. So I get 0 equals log 2 to the 2x plus 6. So I can only convert to exponential if there's a positive 1 in front of that log. If there's not a positive 1 in front of that log, I cannot change it to exponential. Okay? If there's a number there, I have to divide it over. If there's a sign there, I have to divide it over. If there's a number at the back, I have to add it over or subtract it over before I can convert. So now I can convert. 2, base of the log becomes base of my exponent, to the 0 equals 2x plus 6. 2 to the 0 is 1. 1 equals 2x plus 6. Subtract my 6 over, -5 equals 2x divided by 2. Okay? So this one here, the x-intercept of the function of this, they want x-intercept, so y equals 0. So we're going to get 0 equals log a x minus d. If we're missing the variable beside the log or in the base of the log, we convert to exponential. That's what we do every time. That's how we find them. Okay? So a to the 0 equals x minus d. A to the 0 is 1. 1 equals x minus d. Add your d over. Eight. The graph of y equals log x is transformed to the graph of y equals log 2x plus 5. Before I even read that question, I'm going to go log 2x plus what? 5 over 2. So it says by a horizontal stretch about the x-axis by a factor of p, so horizontal stretch equals p, and a horizontal translation q units left. So what's my horizontal stretch? What is going on? 1/2. So we always have to flip it, right? And then it's 5 over 2 to the left. So 1/2 plus 5 over 2, because one's p plus q, 6 over 2. And then an equation of the asymptote y equals 3 log 4 x plus 2 minus 6. Which one is it going to be? It's normally at x equals 0. X equals -2, because we moved it 2 to the left.